So what is heat? It is a form of energy transferred between two systems or system and surroundings between si- by temperature difference. What is temperature? It is a measure of degree of hotness or coldness of the body. So we all know the ideal gas equation is this PV equals to nRT, where P stands for pressure and V stands for volume and N stands for number of moles and R stands for universal gas constant, and T is the temperature. So let us see about two gas laws. It is Boyle's law and Charles' law. So what does Boyle's law says? The volume of given mass of a gas at a constant temperature is inversely proportional to its pressure. So when the temperature is constant, if the pressure is increasing, then the volume is decreasing, or if the volume is increasing, pressure is decreasing. So that is what is said by the Boyle's law. So V is inversely proportional to P, that is V is proportional to 1 by P. So V equals to constant into 1 by P. So PV equals to constant. So this is what is Boyle's law. What is Charles' law? At a constant pressure, volume of given mass of gas is directly proportional to temperature. So when the pressure is constant, if the temperature is increasing, the volume of the gas will increase. If the temperature is decreasing, volume of the gas will decrease. So this is what is called Charles' law. So absolute temperature is the temperature at which the molecular motion completely ceases. So we will see about it later. So now let us move into another equation. Temperature at Kelvin equals to temperature at degree Celsius plus 273.15. So this is how we convert a temperature in degree Celsius from Celsius to Kelvin. So please remember this equation. So now let us see about the Celsius and Fahrenheit scales. Okay. So if we take Celsius scale, the freezing point is 0 degree Celsius and the boiling point is 100 degree Celsius. So if we take Fahrenheit scale, the freezing point is 32 Fahrenheit and boiling point is 212 Fahrenheit. So if this is the suppose let us take these other two scales, which is this is Celsius scale and this is Fahrenheit scale. So this is the lower point, that is 0 degree Celsius freezing point, and this is the boiling point 100 degree Celsius. So here this is the freezing point 32 Fahrenheit and the boiling point is 212 Fahrenheit. So how many divisions it has? So 100 minus 0, that is 100 equal parts. So this scale is divided into 100 equal parts. Similarly 2 and 2 minus 32, it is 180. So this scale is divided into 180 equal parts. So we have to understand that. So please remember this equation. This will be useful to solve some questions also. Temperature at degree Celsius minus freezing point of degree Celsius by boiling point in degree Celsius minus freezing point in degree Celsius. Okay, that is equals to temperature in Fahrenheit minus freezing point in Fahrenheit by boiling point in Fahrenheit minus freezing point in Fahrenheit. So what are we doing here? So here we are taking the temperature at degree Celsius, okay, and minus freezing point in degrees, that is the lower point, by the upper point minus lower point. So here it is temperature in Fahrenheit minus the lower point of Fahrenheit by upper point minus lower point. That is what is given. So if we know this and this we know, and if we are interested in finding suppose 25 degrees Celsius, what is the value of 25 degrees Celsius in Fahrenheit, then you can substitute 25 here and you can find the value of TF, that is Fahrenheit. So I'm substituting the values, that is upper limit and lower and upper point and lower point. So T at degree Celsius minus 0 by 100 minus 0. So here we are taking the boiling and freezing points of Celsius scale. So temperature in Fahrenheit minus 32 by 2 and 2 minus 32. So that is C by 100 equals to F minus 32 by 180. So C by 5 equals to F minus 32 by 9. So this is the simplified formula. So if we want 25 degrees Celsius in Fahrenheit, then instead of C you can write 25 and you can get the answer for F. So yes, you can do questions based on this. So there is a relation that P is directly proportional to T. So we will study this in gas laws. So once we are studying that, you may get. So P is directly proportional to T. That means the graph between P and T will be a straight line. So here we have drawn the graphs for three gases, that is gas 1, gas 2 and gas 3. And Yes, now let us see what is that absolute zero is. So we have already told temperature is directly proportional to pressure, or pressure is directly proportional to temperature. So if temperature is decreased, we find the pressure is also decreased. So when temperature reaches a certain level, the gas has been converted into liquid. So if the gases are converted into liquid, the gas laws cannot be applied anymore because it is a liquid. So we extend the graphs and we can see at a point the graphs are meeting. Okay, so that is this point. So at certain point they are becoming liquid. So after that those gas laws are not applicable. So we are just extending the graphs, all the graphs, so that it is meeting a point. So this indicated a fact that activity of atoms, energy, pressure all will become zero at some temperature, that is same temperature, whatever may be the gases. So that is absolute zero of or thermodynamic zero. So that is called as 0 Kelvin or absolute temperature. So please remember that. Now let us see the concept of thermal expansion. When a material is heated, its temperature rises, then its size increases. So this phenomena is thermal expansion. So it is given. If we raise the temperature, then the size of the body increases, and that is called as thermal expansion. So there are three types of expansion. That is linear expansion, aerial or superficial thermal expansion, and volumetric expansion. So linear expansion says it is increase in length. So similarly, aerial expansion is the increase in area, and volumetric expansion is increase in the volume. Now let us see detail about them. So here it is shown about the linear expansion. So initially the length of this rod, let us suppose assume this to be a rod and which is of length L, and because of heating there is a small rise in the length, that is delta L. So that delta L is nothing but the change in length, that is the rise. So in length L, increased length is delta L. So in length 1 meter, the decreased L will be. So you can consider it like this. So for L length, the length increased is delta L. So what will be for, this is for L meter. So for what will be for 1 meter? So for L it is delta L. So for 1 meter it is delta L by L. So in delta T rise in given temperature, the expansion is delta L by L. Then 1 degree rise, so it is delta L by L delta T. So let us try to understand this. So this delta L by L is nothing but a fractional change. Okay, so delta L is absolute change and delta L by L value gives us the fractional change. So in delta T rise in temperature gives an expansion, that is gives a fractional change of delta L by L. Then what will be the condition for 1 degree rise? It is delta T. For delta T it is delta L by L. So for 1 degree Celsius it is delta L by T, delta T L. So that is the thing. So this is called as, that is the fractional change in 1 degree rise, that is called as coefficient of linear expansion, that is alpha, and that is equals to delta L by L delta T. So from this what we can write, delta L is equals to L alpha delta T, and this will be useful in many cases. So please remember this, delta L equals to, that is delta L is equals to L alpha delta T. So where L is the original length and alpha is the coefficient of linear expansion and delta T is the change in temperature. So now what is this? This is new length. Okay, new length is initial length plus the change, that is new length added. So that is L plus delta L. So L equals to L plus, instead of delta L we can write L alpha delta T. So L equals to L naught into 1 plus alpha delta T. So this is the equation which we have to keep in mind. So now let us see about the aerial expansion. So if the old area is, that is initial area is L square, and what will be the new area? It is L plus delta L whole square, because if suppose this was the thing earlier, suppose let us consider this piece of square and this length is L and this length is L. So now on heating, so this length is also getting increased and this length is also getting increased, so it is becoming a bigger square. Okay, so this, suppose this length is delta L and this length is also delta L, then what will be the new area? L plus delta L. This is L plus delta L, so it is L plus delta L whole square. So this we get L square plus 2L delta L plus delta L square. Okay. Now this delta L square will be very small because delta L, it may be a small increase, and delta L into delta L, it will give another again very small value. So we can neglect this. So what is delta A? It is L square plus 2L delta L minus L square, that is final area minus initial area. So that we get it as 2L delta L. So from this, what are we doing? So here please note one thing. So previously I have told delta L is L alpha delta T. I have shown it here. Similarly, delta A equals to A beta delta T. So where beta is nothing but a coefficient of areal expansion. Okay, this equation remains same. That is delta A equals to A beta delta T, delta L equals to L alpha delta T. So now from this we are writing beta equals to delta A by A delta T. And what is the value of delta A we have found? That is 2L delta L. So 2L delta L by, what is the initial area A? That is L square. L square into delta T. So this is the value of delta A. And now cancel this L and this one. So 2 delta L by L delta T, where delta L by L delta T is alpha. So from this we are getting another conclusion that beta equals to 2 into alpha. So please note this. So similarly we can say the coefficient of volumetric expansion, that is gamma, equals to 3 into alpha.